I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
We've all been there, running on no sleep, trying to push through a long day after pulling it all-nighter. Now imagine doing that while flying a fighter jet at supersonic speed, pulling G-forces and making split-second life-or-death decisions. For most of us, sleep deprivation means a bad day. For a pilot or soldier, it could mean mission failure. That's why, for decades, militaries have relied on stimulants, caffeine, modafinil, and even prescription drugs like dextroamphetamine to stay awake and alert. They work, but at a cost. Sure, they boost alertness, but they also cause jitteriness, anxiety, and sometimes dangerous mood swings. And when the mission ends, the crash hits hard. These drugs linger in the body, wrecking natural sleep cycles. And over time, that chronic exhaustion takes its toll. Slower reaction times, memory issues, even immune problems. Now imagine if you could turn alertness on only when needed and then simply switch it off again when the job's done. That's the bold vision behind DARPA's AWARE program, short for Advanced Wakefulness and Response Enhancement. This isn't just another pill. It's a complete rethink of how we manage the brain's chemistry, combining cutting-edge photonics, neuroscience, and molecular engineering into a system that can literally control wakefulness with light. Here's how it works. At the heart of AWARE is a new kind of smart drug called PhotoDex, a photoswitchable version of dextroamphetamine. Unlike traditional stimulants, PhotoDex stays completely inactive inside the body until it's triggered by a specific wavelength of near-infrared light. Think of it as a drug that only works when you shine the right light on it. The idea is simple but revolutionary. A pilot takes a dose of PhotoDex before a mission. When peak alertness is needed, a specialized wearable like a helmet insert or flexible headband emits near-infrared light pulses aimed at specific brain regions. That light switches on the PhotoDex molecule, boosting alertness and focus in just those targeted areas: the prefrontal cortex, the thalamus, and other centers linked to attention and decision-making. And when the mission ends, a different pulse of light flips the molecule back to its inactive state. No crash, no lingering stimulation, no disruption of natural sleep cycles. This is part of a new field called photopharmacology, using light to control how drugs behave inside the body. These molecules are designed with light-sensitive components, tiny molecular switches that change shape when illuminated. In one form, the drug is inert. In another, it locks onto neural receptors, enhancing dopamine activity and keeping the mind sharp. DARPA's engineers are pushing this to military precision. They're developing helmets capable of delivering near-infrared light deep enough to reach critical brain regions, safely, non-invasively, and with pinpoint accuracy. Because NIR light can pass through bone and tissue, it's perfect for stimulating neurons without surgery or implants. And there's more. To fine-tune activation, researchers are exploring upconversion nanoparticles, special materials that absorb NIR light and re-emit it as visible or ultraviolet light. This could enable even more precise control of how and where the PhotoDex molecules activate, almost like programming the brain's chemistry in real time. The program is rolling out in phases. Phase 0 focuses on developing the drug and testing NIR light delivery systems in lab models. Then come rodent and primate studies, assessing cognitive performance and safety. By Phase 2, the goal is human trials, showing that the combination of PhotoDex and wearable NIR stimulation can restore alertness after sleep deprivation without traditional side effects. It's a massive challenge, ensuring the light penetrates deeply enough, verifying the molecule's stability, and confirming that repeated activation and deactivation don't harm brain tissue. But if successful, it could redefine how we think about cognitive enhancement. And it's not just for soldiers. Imagine emergency doctors, astronauts, or disaster response teams using on-demand alertness during critical hours and then switching off for restorative rest. Even patients with sleep disorders or neurological conditions could benefit from the same principles of light-controlled precision medicine. Of course, DARPA knows this frontier raises ethical questions. Who controls when the brain is switched on? Could such tools be misused or become a new form of performance pressure? That's why the program includes built-in bioethics reviews, ensuring that technology is developed responsibly, with soldier autonomy and safety in mind. In the big picture, AWARE isn't just about staying awake. It's about changing how drugs work altogether. Instead of chemicals flooding the whole brain, we'll soon be able to activate medicine only when and where it's needed. Painkillers that respond to injury sites, antidepressants that target one neural circuit, therapies that switch on and off like a light. DARPA's vision goes beyond chemistry. It's about building a future where biology itself becomes programmable. And one day, the power to stay sharp, focused, and fully awake might truly be just a flick of light away. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.